To be sampleable also means that you have to have fine regoliths with the grain size or pebbles not larger than 2 centimeters in diameter.
Because you need to, how does it work? You push.
Yeah, basically it's an arm that is extended. It's about 2 meters, and at the end there is this TAGSAM. It's a sample acquisition mechanism. Looks like a filter, air filter of a car, right? But there are basically 3 nitrogen bottles associated to that, and when the surface is touched, right, it's sensed through an accelerometer. Basically, the accelerometer triggers the bottle of nitrogen. This gas, it's called gas, is shoot through the mechanism into the surface because of the low gravity. The idea is that to mobilize the surface, eventually there is an opening that collects all this regolith with the diameter less than 2 centimeters, then close it, right? And it can acquire as much as 2 kilos of material. Okay.
And how fast is the spacecraft going down?
So the requirements, this was designed, it was no more than 10 centimeters per second vertical velocity and no more than 2 centimeters per second lateral velocity. So those are the constraints, and usually you are in a free fall from about 50 meters altitude.
Okay, so
you're going down.
Stop control. I mean,
yes,
it stopped itself because it's going to be autonomous, even the navigation.
Well, so the nominal plan, which was when we designed the whole touch and go maneuver, it was supposed originally to be with pretty much open loop, which means ground in the loop. Okay. And what it means that the sequence of commands, right, or barns that are executed during the mission are really pre-planned from the ground, uploaded to the spacecraft, and then executed according to a certain time, right, clock. And it consisted basically, so the spacecraft would be in a safe home which is a polar, terminator orbits, about 1 kilometer altitude, not altitude, 1 kilometer's radius orbit, so about 700, meter, 750 meter altitude. You execute an initial burn. You coast for quite a while. Eventually, when you are 125 meters, to go, you execute another burn. Once you are about 50 meters, you then do the last and final burns that basically match the angular velocity of the asteroid, and you go as vertical in a coasting phase. Once you touch the surface,
as soon as you touch, there's another burn.
Yes, it's after 5 seconds, right? Usually estimated. Then there is another burn that will bring you far away from the asteroid, talking about a few kilometers, where you can do safely some measurements of the sample, to estimate if
you got something.
You got something, right? It turns out that the way we measure those things is by basically doing the slew maneuver around one axis, right, before and after the sampling. Basically, what you're measuring is the difference in moment of inertia, and there is a sensitivity of about 60 grams, 50-60 grams. So we expect to get as little as 60 grams, as much as 2 kilograms. 2 kilograms. So, and you have 3 attempts, right? If after the first touch and go, you do the measurement, you see that you're below 60 grams, that means you're in uncertainty measurements, then you have to go back. Of course, even there, it's going to be probably depending how close you are to the 60, because then you have a trade-off of risk versus reward, because at the end of the day, executing the maneuvers over and over, it increases the overall risk, right?